Okay, this is video number 16, logarithm. We started this function in video number 15, and you can check we did all these, right? The function was f of x equal ln x plus 1 over 1 minus x, and we got two vertical asymptotes, which is x equal minus 1 and x equal 1, no horizontal asymptote. I'm going to draw this. You can go back to the previous video to check how we did it. The red lines are the asymptotes, are the vertical asymptotes, and we said that it's symmetrical with respect to the origin because it's an odd function. So simply, and it's strictly increasing, goes from minus infinity of minus 1 plus to plus infinity of 1 minus, right? So simply, it's very simple to draw this curve. It's very simple to draw this curve. Symmetrical with respect to the origin because it's an odd function. It's something like that, right? Two parts. From minus 1 to 0 is symmetrical from 0 to 1. Two parts. Let me check. Let me do this. It was ln, right? It was ln minus the function is ln x plus 1 over x over 1 minus x, right? X plus 1 over 1 minus x. 1 minus x. Okay, that's it. We can't use brackets maybe. Why? He's highlighting, and so it's ln x plus 1 over 1 minus x. 1 minus x. Oof, that's not true. That is not true. I'm losing some time. Okay, I will draw it later, but this is 100% our drawing, okay? This is 100% our drawing. What do we still have? This is part D. This is what the curve C of the function. Part E proved that f admits an inverse function, f inverse whose domain is to be determined. First, to have an inverse function, part E, right? To have an inverse function, simply, it should be continuous and strictly monotonic, right? F is continuous over minus 1, 1, and strictly increasing, we proved that in the previous video, over the domain minus 1, 1. This means, yes, F inverse exists. This is the existence of F inverse. Now, what is the domain of the function F inverse? Because whose domain is to be determined. What is the domain of the inverse? We know that the function f goes from minus 1, 1, as you can see at the table of variation, from minus 1, 1, as x minus 1, y minus infinity, as x1, y plus infinity, right? So it goes from minus 1, 1 to the range minus infinity plus infinity. And you can go back to inverse functions. I did like 12 videos. It goes from minus infinity, right, to plus minus infinity plus infinity to minus 1, 1. So what is the domain of inverse function? Its domain is simply from minus infinity up to plus infinity. This is the domain of the inverse function. What else we do have? We do have part E, part F, right? F and G. Plot C prime, which is the representative curve of F inverse in the same system of C. We have to plot in the same system of C. To do so, it's on the graph, right? It's just on the graph. First, we find y equal x, right? If you remember, we have the line y equal x. Which is the first bisector. Y equal x. This is y equal x. This is the line y equal x. Suppose this is the line y equal x. So it's the first bisector because it's going to be symmetrical with respect to the first bisector. First y equal x. Second, the vertical asymptotes becomes horizontal asymptotes if you remember. Let's say this is 1, right? This is 1 over here. And this is minus 1 for y. So this here we have also horizontal asymptote, which is y equal 1. It was x equal 1, now it's y equal 1. It's horizontal asymptote, not vertical asymptote, because we are drawing the inverse, right? We're drawing the inverse function. And y equal minus 1. Y equal minus 1 instead of x equal minus 1. So this is y equal minus 1. So what do we have over here? We have okay, I don't know how it turns to black, but it's all right. Let it be black. Let me make it. This is asymptote, right? This is a horizontal asymptote. Okay, and this is the other horizontal asymptote. And simply, it goes from minus infinity to plus infinity. This means it goes from minus infinity to plus infinity. So it goes from minus infinity of asymptote minus 1. It goes all the way to have tangent over here. And then it goes away to the other asymptote, to plus infinity. That is C prime, which is the curve of the inverse. And this is C, which is the curve of the function. This is part E. We still have part F and part G. Part F says, we did part F, right? Now part G. Calculate part G and part H. This is part H over here. Calculate F inverse prime of 0 in 2 different ways. You remember we did that in the videos of inverse functions, right? In the videos of inverse functions. You can go and see how we did these. So we need to find the F inverse prime at point 0 in 2 different ways. If you remember, we got a rule that F inverse prime of y, right, is equal to 1 over F inverse, F prime of x. It's a rule, and I did this rule in the inverse functions. You can go back to it. But this is a rule. F inverse prime of y is equal to 1 over F inverse F prime of x, sorry. In this case, if y is 0, because here we need F inverse prime of 0. So if y is 0, then x is 0. Then x is equal to 0. Because I did it over here. X is 0 when y is 0, right? So what do we have over here? We have 1 over F prime of 0 is equal to 1 over F prime of 0. We go back to F prime. Which is 2 over x plus 1 into 1 minus x. And we substitute 0, 0. So it will be 2 over 1. The answer is 2 over 1 is 2. So the F prime of 0 is 2. So the 1 over F prime of 0 is equal to half. And this is the F inverse prime of 0. That's great. This is the first method. Second method, how to find that solution in the second method. Second method, what is the expression of F inverse of x? First, F of x is y equal ln x plus 1 over 1 minus x, right? We interchange. Instead of y, we put x, and instead of x, we put y. It's ln y plus 1 over 1 minus y, right? And we go try to go and find y. We multiply the x with ln e to change it to ln, because we have ln to this side, which is ln 1 y plus 1 over 1 minus y. And now it's ln e power x, right, equal to ln y plus 1 over 1 minus y. Ln cancel. What left is e power x